Okay, so today's problem is a vector problem from chapter 1 of the Young and Freedman University Physics books, and it's about University Physics book, and it's an emergency landing. So we have an airplane leaving an airport. It flies in a particular direction for a particular distance. It changes direction and flies in that direction for a particular distance, and then it makes an emergency landing. So the airport then sends out a rescue crew, and we're trying to figure out in which direction and how far should this crew fly to go directly to the plane. So the first thing you need to do in all of these problems, vector problems specifically, but almost all problems you tackle in physics, is to draw a diagram and figure out what you know and what you need to find out. So we'll make this problem a little bit smaller here to give us a little bit more space. And we'll set up the problem. So we'll draw ourselves out a coordinate system here. So this is going to be our north, and this is going to be our east, on a very straight line along the x-axis. So this north along the y-axis, east along the x-axis. So what we're told in the problem is, if we just zoom up again, is that the plane leaves the airport and flies 170 kilometers at 60 degrees east of north. So 170 kilometers at 60 degrees east of north. Looks something, I think it was actually 68 degrees. Let's put this in a different color. So let's put this in red and trace that out. So this is around, let's call this 170 kilometers, 170 km, and this is 68 degrees. Great. So the airplane then changes its direction and heads off in a direction, let me see what we say, 36 degrees south of east from there, and it makes an emergency landing at 230 kilometers. So my y-axis could have been a little bit bigger here, or a little bit longer. So let's get rid of that. This guy here. Oops, that didn't do it. Yeah, okay, let's get rid of this, and let's extend our x-axis out a little bit further. Oh, wrong color. Still getting used to this iPad. Oh, we go all the way out then to east, which is our x-axis. Lovely. So now 36 degrees south of east is the way our airplane flies after that. So we go back to, let's call this one, let's put this one in blue, and we're flying roughly in this direction here for 230 kilometers. So we got 230 km, and we've got an angle that's 36 degrees south of east. So if the blue line here was east, this would be 36 degrees south of east. So now we've got our two vectors representing the distance traveled by the airplane in the two segments of its flight. The red one is the first segment, the blue one is the second segment, and ultimately what this problem wants to do is for us to calculate the resultant vector of the two, which, if we use green and draw it in here, looks something like this. So we'll give it an arrowhead, and we'll give it a capital R for resultant, which is the notation we tend to use, and an arrow there. So we've got 170 kilometers, 230 kilometers. Now we need to do a little bit of maths. So we'll call this vector, okay, let's go back and do some more notation. So we're calling this A, and then we're going to call the blue one B. And what are we looking for? We're looking for the sum of A and B, which is equal to R. Now that's the vector sum. So back to black here, we can say that the sum of vector A plus B is equal to the resultant vector R, which we have there. And we know what A and B are from our diagram. So we're going to split this up into vector components. So anytime we're adding a vector, in 2 dimensions in this case, we're going to look at the x components and the y components. So first of all, we split it up into its x components, and we say that the x component of R is equal to the x component of A and the x component of B. So we're just looking along the x-axis so far, and we're looking at the x component of the two. When we add those two together, that's going to give us the x component of our resultant vector. So the x component of vector A is going to be 170 kilometers, which was the length of our vector, times the sine of the angle that that vector makes with the x-axis, which is 68 degrees, which is what we have here. So 170 times the sine of 68. The B, or the x component of B, then is going to be 230 kilometers, 230 kilometers, times the cosine of 36 degrees. So cosine 36 degrees. So this angle here is the 36 degrees, and the x component of this vector here, if this angle is 36 degrees, the x component of this vector is going to be given by the cosine of the angle that it makes with the x-axis here. So that's 36 degrees. So the resultant there gives us 343.7 kilometers. So the total sum of the x components is 343.7 kilometers. Let's get rid of my pens here. Can't get rid of them. Okay, the y component then. So the y component of our resultant vector, or y, is going to again be the y component of A plus the y component of B. So what are our y components? Well, the y components here are 170. 170 is the length of vector A times now the cosine of 68 degrees. So cosine 68 degrees, which is the angle that it makes with the x-axis here, which we've shown already. And the y component of vector B is negative. So the vector A is heading in the positive y direction, and vector B is heading in the negative y direction. So we need a minus sign here, and we get 230 kilometers again times the sine of 36 degrees. Sine 36 degrees. And that gives us a total y component of minus 71.5 kilometers. So the minus sign tells us that the resultant vector is going to be below the y-axis. It's going to have a negative y component, which is what we expect when we draw the diagram, and that's what comes out of the maths when we do it. So now all we need to do, is find, the sum of the two, find the resultant vector. So the resultant vector, its magnitude is going to be the square root, as we know, of rx squared plus ry squared. So that's a very simple case of just plugging in the numbers, and we get the square root of 343.7 squared plus minus 71.5 squared, which was our y component. And when we do that quick calculation, we get 351 kilometers. So 351 kilometers is the magnitude of that vector. The last thing we want to do then is, is make a calculation of what this angle is here. So if we call this angle theta, what is that angle theta? And we can calculate that by knowing that the tan, so the tangent of this angle theta, or, so we call it theta r, is equal to the magnitude of the y component of r over the magnitude of the x component of r. So this angle here, we look at the x components and the y components of our resultant vector r, and the tan of that angle is equal to the y component over the x component, which is 71.5 over 343.7, which gives us 0.208. And if we take the inverse of that, then we get theta r is equal to 11.8 degrees south of east. And that one solves that, or that solves that one for us. So a fairly straightforward graphical vector problem for you to solve.